Well, good day, algebra students. We are almost done with the semester. Um, this is on adding rational expressions part 2. So I want to talk to you about the prime factorization method, okay, of adding fractions. And so we're going to do it for regular rational numbers, and then we're going to do it for algebra and go from there. So that's kind of our goal for today. And so if you kind of stick with me through the process, we will do that. All right, here we go. All right, the first problem I want to do is I want to do 1 over 120, or let's do like 17 over 120 plus I'm thinking, let me do something like 6 over 45. Okay? So, what I need to do is I need to find a common denominator between 120 and 45. And so, the way I would do that is find the least common multiple. Now, I've showed you guys a couple of methods in class before. And I want to review those right here. One method is to just make a tree diagram where you prime factor each of these numbers. All right. And, okay. So now we have the prime factorization of each of them. In fact, 120 we can write as 2 cubed times 3 to the 1 times 5 to the 1. And 45 we can write as 3 squared times 5 to the 1. All right, so to find the least common multiple of 45 and 120, all you have to do is write down each prime factor that you see in both numbers. So I see a 2, I see 3, and I see 5. Those are the prime factors. Then what you do is you choose the largest exponent of each one that appears. So for instance, on the 2, we have a 2 cubed in the 120, and we have essentially 2 to the 0 power in the 45. So we choose the largest exponent, so it's 2 cubed. Then we have 3 to the first and 3 squared. So we would choose the largest exponent, 3 squared. And then we have 5 to the first and 5 to the first, which is 5 to the first. So our least common multiple is actually 8 times 9 times 5, or 360. All right? And we can now add these fractions. Okay? So let me shrink that up. And so now we go to add these fractions. We have 17 over 120 plus 6 over 45. That's going to equal something over 360 plus something over 360. Now, 360 is this expression right here. It's 2 cubed, 3 squared, and 5 to the first. And so what's missing on the 120? Well, what's missing is just a 3, because we have 3 to the first instead of 3 squared. So 3 times 17 is 51. That gives us the new numerator. And 3 times 120 is the 360. Well, what's missing on the 45? Well, 45 has 3 squared and 5 to the first. So what's missing is the 2 cubed, or 8 over 8. And so 8 times 6 is 48. 8 times 45 is 360. So now I can add these fractions, 99 over 360. Now, I already know that 360 is 8 times 9 times 5. So 99 is 9 times 11, so the 9's cancel. And our final answer is 11 over 40. Okay? Now, it just so happens every time you add, you have to check if it simplifies. But notice, I've already got the breakdown of the 360, so I can use that to help me figure out what goes in both the numerator and the denominator. Okay? And so we move forward from that point. Okay? Now, just so you know, this was the way I learned how to find least common multiples when I was in school. And I have told you guys that all our friendly students from Nepal and students I knew from India do it this way. They just look for prime factors that go into both numbers. Those 3 goes into both numbers, so I get 40 times 15. And then 5 goes into both numbers, so I get 8 times 3. And then there's nothing that goes into the 8 and 3. So the least common multiple is going to be 3 times 5 times 8 times 3. Or if you wish, 8 is 2 times 2 times 2. You can break that down. And there's all the prime numbers, and that's exactly what we got right here. And so it gives us the same method. So I find this a very quick strategy to find a least common multiple, and I recommend you start using it. And once you do that, you get the 360, and then the problem proceeds forward in much the same manner. Okay? Alrighty. That's the method we're going to use for algebra. Okay? So let's go on. So in general, what we have to do with adding fractions, suppose we add 4 over x plus 3 over x minus 5. Well, if I want to add those two fractions, then this is really easy in this case because the x and the x minus 5 don't factor. And so when you have a denominator that doesn't factor, your common denominator is just x times x minus 5. So all I have to do is find the new numerators. So this fraction, I multiply by x minus 5 over x minus 5. That gives me the denominator. And this one I just multiply by x over x. And so 4 times x minus 5 is 4x minus 20. And 3 times x is 3x. And so that leaves me with 7x minus 20 over x times x minus 5. Now I think, does the numerator factor? The answer is no. So I am completely simplified and I'm done. All right. So this is the basic strategy for doing fractions. Now I'm going to do a few more examples. I recommend highly that you look at all the examples in the textbook as well, because the more examples you see, the more you'll kind of know what to expect with little situations. So sometimes you have denominators like this where you just multiply them to get the common denominator because they have nothing in common. However, here we can use our prime factorization rule. Notice we have x minus 1 to the first power and x minus 1 squared. So the common denominator is x minus 1 squared. Okay? And so therefore, the second part doesn't change at all. We just have minus 3. And the first part, we have to multiply by x minus 1 over x minus 1 to get the x minus 1 squared in the denominator. And so that becomes 7x minus 7. Again, we collect like terms, 7x minus 10 over x minus 1 squared. 7x minus 10 does not factor, so this is our final answer. All right. Let's go to another problem. I think I like this one right here. Let's try this. 2x plus 9 over x squared minus 7x plus 12 minus 2 over x minus 3. Now, in this case, this denominator is not factored. So generally, step one is always factor the denominators so you can see what you have. This factors into x minus 4, x minus 3, minus 2 over x minus 3. And so now we can see they both have an x minus 3, and there's an x minus 4 to the first, so we need to have that in the common denominator. So the common denominator is x minus 4 times x minus 3. All right. And therefore, we multiply this one by x minus 4 over x minus 4. Okay. And therefore, we get the 2x plus 9, which is already over the common denominator. And then we get a negative 2 times x minus 4, so minus 2x plus 8. And this will give us 17 over x minus 4 times x minus 3. And there's no canceling there, so that's our final answer. So this one has two denominators, neither are factored. So our first step is to factor them. So this is equal to x plus 3 over x plus 2 times x minus 1 minus 2 over x plus 1, x minus 1. And so what we see is both of these have an x minus 1, so that's in the denominator. And then we need the other factors as well, so x plus 2, x plus 1, all raised to the first power, so there's our common denominator. So what's missing on this side right here? An x plus 1. So we multiply by x plus 1 over x plus 1. And what's missing here? An x plus 2. So we multiply by x plus 2 over x plus 2. And that will give us our common denominator in each case. So the numerator here is x plus 3 times x plus 1 minus 2 times x plus 2. So now that I have that, I can go ahead and multiply it. So this will be x squared plus 4x plus 3 minus 2x minus 4. Making sure I multiply through that negative over the common denominator, which doesn't change. And I never multiply the common denominators back. Okay? At this point, I can subtract x squared plus 2x minus 1 over x plus 2, x plus 1, x minus 1. Now I have to check if the numerator can factor, and I can cancel. But since this is negative 1, I only get minus 1 plus 1. And so x minus 1 times x plus 1 is x squared minus 1, not x squared plus 2x. So this is all the way simplified, and I'm completely done. All right? So that's the kinds of strategies that you do on these problems. So I want to wish you luck on the homework. You have a few review ones, and then there's a couple practice plus. On the practice plus, you just have 3 denominators. You're trying to get common denominators. But the strategy is the same. All right. Thank you very much. See you next time. Bye.